Hey everyone, welcome back. I hope all of you've been doing great. Today I'm bringing you this very complete and comprehensive space iceberg, and it actually could be the best iceberg made on the subject of space. I selected this one, and there's just one thing I want to say before we begin the video, and it's that you should probably skip the first 3 entries, which are about the 8 planets, the sun and the moon, because I just think these are topics that are pretty well known. So you're probably already familiar with whatever these 3 entries contain. But that's just what my opinion is, and maybe I'm wrong and you totally want to hear about them. So for this reason I've included them as well instead of just skipping them. So you have the option whether to skip or not, instead of me deciding that for you. Alright, starting the iceberg with Tier 1's first entry, the 8 planets. Mercury, only slightly larger than our moon, is the planet closest to the sun. Like our moon, it's covered in craters, and its proximity to the sun makes it scorching hot, with surface temperatures around 360 degrees Celsius. Venus, the brightest natural object in our sky after the sun and moon, owes its brilliance to its closeness relative to other celestial bodies. While Mercury is hot, Venus takes it to another level. Despite being farther from the sun, its atmosphere is about 100 times thicker than Earth's, trapping immense heat and pushing surface temperatures to a blistering 465 degrees Celsius, making it the hottest planet in our solar system. Earth, our home, is a vibrant mix of blue, green, and white, dotted with clouds, and it's the only planet known to support life. Mars, known as the red planet, gets its hue from the iron oxide coating its surface. It's the most viable candidate for human colonization, with long-term plans already in motion. Mercury and Venus are too hot, and the gas giants are both too distant and composed mainly of gas, making them uninhabitable. So for now, Mars is our best bet. These 4 inner planets form the first part of our solar system, followed by the asteroid belt, and then we reach the outer planets, starting with Jupiter. Jupiter is a gas giant, and giant is the key word, though gas is also crucial since it's composed mostly of hydrogen and helium, much like our sun. However, Jupiter isn't massive enough to ignite nuclear fusion and become a star. This colossal planet could fit all the other planets in our solar system inside it. Its surface is home to a massive storm larger than Earth itself, and it boasts the solar system's largest ocean, not of water, but of liquid hydrogen. Saturn, another gas giant, is so light that if you could find a bathtub large enough, it would float on water. Saturn is famous for its elegant rings made of icy rock and rocky ice. It also holds the record for the most moons in our solar system, with a staggering 145. Uranus, though unfortunately named, is actually the coldest planet in the solar system. And that's all we'll say about Uranus. Neptune, often compared to Mars for its distinctive blue color, owes its hue to its atmosphere, which contains about 1% methane. This methane absorbs red light, reflecting blue light back to us. Neptune also has the most powerful winds in the solar system, with gusts up to 6 times faster than the strongest wind ever recorded on Earth. Finally, we come to Pluto, which, while no longer classified as one of the 8 planets, was once part of that elite club. Pluto is a small, icy rock with just 1/6 the mass of our moon and roughly half the size of Australia. Its orbit even crosses Neptune's, meaning that for about 20 years of its 248-year orbit, Pluto is actually closer to the Sun than Neptune. The Moon. Forget everything you know about the Earth and the Moon's orbit because it's not quite what you think. The actual ratio between Earth, the Moon, and the space between them is astonishing. The gap is so vast that you could fit all the other planets in our solar system into it. It probably formed when a planet about the size of Mars collided with Earth during the early days of our solar system. The collision ejected debris into space, which eventually coalesced into the Moon we see today. The Moon is what we call tidally locked to Earth, meaning it rotates in perfect sync with its orbit, so we only ever see one side of it. The Sun is a pretty standard star in terms of size and has been shining for about 4.6 billion years. Without it, we'd be plunged into darkness, freezing cold, and completely lifeless. The Sun gives us everything we need: light, warmth, and energy. So it's no wonder ancient civilizations like the Egyptians with their sun god Ra revered it so much. Oh, and fun fact, The Sun makes up 99.8% of the total mass of our solar system. The search for life beyond Earth. The search for life addresses the age-old question, does life exist outside our planet? Mars is the primary candidate in our solar system for potentially hosting life, though the search mostly revolves around life forms similar to those on Earth. However, when it comes to truly alien life, we might not even know what to look for. It could be so different that we've already missed it. Killer asteroids, planet-destroying asteroids, are massive space rocks capable of causing extinction-level events. The most infamous of these is the asteroid that struck Earth around 65 million years ago, known as the Chicxulub impactor. Measuring about 6 to 9 miles in diameter, it collided with Earth in what is now Mexico, wiping out 70% of Earth's species, including the dinosaurs. The impact caused enormous tsunamis with waves reaching from Mexico to Texas, Florida, and beyond. Debris from the collision was ejected so high that it temporarily left the atmosphere before raining back down as a fiery storm, igniting wildfires and possibly burning down Earth's forests. The colossal shock waves triggered global earthquakes and volcanic eruptions. A dust cloud from the impact spread across the planet, blocking sunlight for years, causing temperatures to plummet. As of 2022, scientists have identified 2 large asteroids near Earth that could pose a future threat. Neil Armstrong. Neil Armstrong made history as the first person to walk on the moon in 1969. Meanwhile, satellite TV works by broadcasting signals from a TV station to satellites in space, which then relay the signals back to Earth, where they're picked up by your satellite dish and displayed on your TV. Space is a vacuum because the air pressure is almost non-existent. There's no atmosphere, so there's no air to breathe. On Earth, air has mass, with 1 cubic meter of air at sea level weighing about 1.3 kilograms. Space Shuttle. The Space Shuttle was a reusable spacecraft operated by NASA for low Earth orbit missions. Over the course of 135 missions from 1981 to 2011, 5 different shuttles were launched and flown by astronauts. Pioneers of space, Yuri Gagarin, a Soviet cosmonaut, became the first human to journey into outer space. He orbited the Earth aboard the Vostok 1 capsule on April 12, 1961. The Big Bang theory is a scientific explanation for how the universe began. According to this theory, the universe started as an incredibly dense point that exploded with unimaginable force, creating matter and propelling it outward to form the billions of galaxies that make up our vast universe. The silence of space. Space is completely silent because sound requires a medium, like air or water, to travel through. Since space is a vacuum with no air, sound has no way to propagate, making it a silent void. Pluto's planetary status. In August 2006, the International Astronomical Union reclassified Pluto as a dwarf planet. However, the debate over Pluto's status continues. In 2019, NASA Administrator Jim Bridenstine stated that, in his view, Pluto is still a planet, reflecting the way he was taught and his personal commitment to that perspective. The International Space Station, ISS. The ISS is the largest modular space station in low Earth orbit, developed through the collaboration of 5 space agencies from 15 countries. Currently, there are 7 astronauts living on the ISS, where they will spend around 6 months. During that time, the space station completes 16 orbits around Earth every 24 hours, experiencing 16 sunrises and sunsets. Constellations. Constellations are patterns formed by groups of visible stars, often representing animals, mythological figures, or objects. The origins of these constellations trace back to ancient times. In 1922, the International Astronomical Union officially recognized 88 constellations that cover the entire sky. We choose to go to the moon. This famous speech was delivered by President John F. Kennedy at Rice University in 1962. It was intended to rally American support for NASA's mission to the moon, with Kennedy promising to land an American astronaut on the moon before the end of the 1960s. Curiosity rover. Curiosity is a car-sized rover created by NASA to explore the Gale crater on Mars. As of May 2023, it has been actively operating on Mars for more than 10 years. Recently, Curiosity uncovered evidence suggesting that an ancient lake once existed on Mars, indicating that the planet could have supported microbial life. The Sun's future. In approximately 5 billion years, the Sun will exhaust its hydrogen fuel. When this happens, it will expand to a size far beyond our imagination, growing large enough to engulf the inner planets, including Earth. This phase will transform the Sun into a red giant, a stage it will remain in for about 1 billion years before depleting its helium reserves. Afterward, the Sun will contract into a white dwarf and slowly fade away, a process expected to take around 7 to 8 billion years. Elon Musk. Elon Musk is the founder of SpaceX, a company dedicated to manufacturing and launching advanced rockets and spacecraft. His primary goal is to reduce the costs of space travel, ultimately making the colonization of Mars possible. Sputnik 1 was the first man-made satellite to orbit Earth. Launched by the Soviet Union in 1957, it entered an elliptical low Earth orbit and transmitted a radio signal back to Earth for 3 weeks before its batteries died. Due to atmospheric drag, the satellite re-entered Earth's atmosphere after 3 months, marking a significant milestone that ignited the space race between the United States and the Soviet Union. Simulation hypothesis. The simulation hypothesis suggests that our entire existence could be a simulated reality, akin to a computer simulation. This theory posits that the laws of physics governing our universe are similar to computer code, which the simulation would follow. Mathematical equations, numbers, and geometric patterns that are prevalent in physics lend support to this idea. Additionally, the universe's maximum speed limit, the speed of light, could be analogous to the processing speed limit of a computer's processor. In a simulation, an overloaded processor would slow down, much like how time is affected near a black hole, according to Albert Einstein's theory of general relativity. Exoplanets. Exoplanets are planets located outside our solar system. As of 2023, there are 5,366 confirmed exoplanets, with 55 of them considered potentially habitable. While most exoplanets orbit other stars, there are also rogue planets that drift through space, orbiting the galactic center without being bound to any particular star. Uranus's unique tilt. Uranus is unusual in that it rotates at nearly a 90-degree angle relative to its orbital plane, making it appear to spin on its side as it orbits the Sun like a rolling ball. In comparison, Earth's axis is tilted at about 23 degrees. According to detailed computer simulations, it's believed that around 3 to 4 billion years ago, a planet roughly twice the size of Earth collided with Uranus, causing it to tilt. The speed of light. The speed of light is approximately 186,000 miles per second. The universe is estimated to be 13.7 billion years old, a figure determined by examining the oldest stars and measuring the rate of the universe's expansion, then working backward to the Big Bang. Black holes. A black hole is a region in space where gravity is so intense that even light cannot escape. This extreme gravity results from matter being compressed into a very small space, which can occur when a star collapses. Because no light can escape, black holes are invisible to the human eye. Scientists believe that the smallest black holes are about the size of an atom, but have the mass of a large mountain. The largest black holes, known as supermassive black holes, have masses equivalent to over 1 million suns combined. Chris Hadfield. Chris Hadfield was the first Canadian astronaut to conduct a spacewalk and served as the commander of the International Space Station, ISS. Over his career, he participated in 3 space missions, contributed to the construction of 2 space stations, and completed 2 spacewalks. Before becoming an astronaut, Hadfield spent 25 years in the military as a fighter pilot, earning recognition as the top test pilot in both the U.S. Air Force and Navy. During one spacewalk, Hadfield temporarily lost his vision while gripping the ISS with one arm. His left eye suddenly shut in pain due to an irritant that turned out to be a drop of defogging oil and soap used in astronauts' visors. In the absence of gravity, the tears from his eye formed a large ball of moisture that traveled across his nose and into his other eye, rendering him completely blind outside the spacecraft. Instead of panicking, Hadfield's training kicked in. He vented some oxygen from his helmet to evaporate the mixture from his eyes and continued with his work. This experience underscored a crucial lesson from his astronaut training: always be prepared for the worst. Throughout his career, Hadfield demonstrated remarkable resourcefulness, once using a Swiss Army knife to break into a space station, safely disposing of a live snake while piloting a plane, and figuring out how to repair an ammonia leak on the ISS. According to Hadfield, overcoming fear requires a combination of boldness and thorough preparation, as fear is often a result of inadequate preparation, and the best cure for fear is competence. Venus spins backwards. Venus rotates in the opposite direction to most other planets, which means that on Venus, the sun rises in the west and sets in the east. One theory suggests that Venus originally spun in the same direction as the other planets, but is now upside down. Another theory proposes that its rotation gradually slowed to a stop and then reversed direction. Michael Collins. Michael Collins was an American astronaut who piloted the Apollo 11 spacecraft, Columbia, during its historic 1969 mission. While his fellow astronauts, Neil Armstrong and Buzz Aldrin, made the first manned landing on the moon, Collins remained in orbit. Although he was offered the chance to participate in future Apollo missions, Collins declined, citing the strain the mission placed on his family life. He felt fulfilled having contributed to John F. Kennedy's goal of landing a man on the moon, and had no desire for further exploration once that objective was achieved. The moon's drift. The moon is slowly drifting away from Earth. During the 1969 Apollo missions, NASA installed reflective panels on the moon's surface, which have since revealed that the moon is receding from Earth at a rate of 3.8 centimeters per year. Scientists believe this drift is influenced by Milankovitch cycles, which describe slight variations in Earth's orbit and axis. Around 2.5 billion years ago, the moon was approximately 60,000 kilometers closer to Earth, meaning that days were shorter, lasting about 17 hours. Supermassive black holes. It is believed that supermassive black holes exist at the centers of all large galaxies, including the Milky Way. Astronomers detect these black holes by observing their effects on nearby stars and gas. Theories about their origins include the gravitational collapse of massive gas clouds from which galaxies formed, the merging of smaller black holes over time, or their gradual growth by consuming nearby stars and matter. Satellites in orbit. As of 2022, there were 8,261 individual satellites orbiting Earth. Modern civilization relies heavily on satellites, and if they were to suddenly stop functioning, global transportation would come to a halt, economies would collapse, and many nations would declare states of emergency. Even in the best-case scenario, the world would be set back by decades. Space shuttle disasters. The Space Shuttle program experienced two major disasters. On January 28, 1986, the Space Shuttle Challenger exploded 73 seconds into its flight, killing all 7 crew members. The spacecraft disintegrated at an altitude of 46,000 feet above the Atlantic Ocean near Cape Canaveral, Florida. On February 1, 2003, the Space Shuttle Columbia disintegrated during re-entry over Texas and Louisiana, also killing all 7 astronauts aboard. The Columbia disaster was caused by damage to the left wing's edge from debris that struck it during launch. Apollo 13. Apollo 13 was the third mission intended to land on the moon, but it was aborted after an oxygen tank exploded 2 days into the mission. The 3 crew members heard a loud bang, leading to the famous line, "Houston, we've had a problem," as reported by astronaut Jim Lovell to Mission Control. Despite the explosion, the crew survived by looping around the moon and safely landing in the South Pacific Ocean. Laika the space dog. Laika was a Soviet space dog and the first animal to orbit Earth. A stray dog found on the streets of Moscow, Laika was launched aboard Sputnik 2 in 1957. To prepare the dogs for the cramped conditions of Sputnik 2, they were confined in progressively smaller cages for up to 20 days, which negatively affected their health. The dogs were also subjected to centrifuges simulating rocket launches, and machines replicating spacecraft noises, which cause their heart rates to double and their blood pressure to spike. After training 3 dogs, Laika was selected for the one-way mission to space. Sadly, about 5 to 7 hours into the flight, Laika's life signs ceased. The tyranny of the rocket equation. The tyranny of the rocket equation refers to the challenge that as a rocket's payload increases, so too does the amount of propellant needed to overcome Earth's gravity. This creates a cycle where more fuel requires a larger fuel tank, which in turn adds more weight, necessitating even more fuel. This is a significant limitation in space exploration because adding fuel leads to increased weight, requiring even more fuel, and so on. Historic supernova. A supernova is a powerful and luminous explosion that marks the final stage in the life of a massive star. Although no bright supernovae have been observed in the Milky Way galaxy since the invention of the telescope in 1610, at least 5 supernovae were recorded in historical texts dating from the medieval period to the Renaissance. These supernovae were documented in the years 1006, 1054, 1181, 1572, and 1604. Stellar classification. Astronomers use stellar classification to categorize stars based on their spectral characteristics, such as the elements they contain, their temperature, density, and magnetic fields. The main types of stars are O, B, A, F, G, K, and M, with M being the smallest and most common, making up about 75% of all stars. O-type stars are the largest and rarest. The color of a star's light is determined by its temperature, with the hottest stars glowing blue and M-type stars emitting a red light. The Sun is classified as a G-type star. TV static. TV static is caused by random radio waves reaching the television from various sources, including deep space. A key contributor to this static is the cosmic microwave background, CMB, which is the residual radiation from the Big Bang. This fossil radiation was released shortly after the Big Bang and is considered an echo or shock wave of the event. The CMB's remnants fill the universe and are responsible for a significant portion of the static seen on a TV screen, the faint glow of the Big Bang. The Kuiper Belt. The Kuiper Belt is a donut-shaped region beyond Neptune's orbit, filled with icy bodies. There may be billions of objects within the Kuiper Belt, which are remnants from the early history of the solar system. Cosmic rays. Cosmic rays are high-energy radiation that originates outside our solar system. When these rays reach Earth, they collide with particles in the upper atmosphere, creating a cascade of secondary particles. Cosmic rays strike Earth's surface at a rate of about 1 per square centimeter every minute. During an average night's sleep, a person will experience about 1 million cosmic rays passing through their body. While cosmic radiation exposes the body to a level of radiation similar to a medical X-ray, the average annual dose is low and not considered harmful to human health. Micrometeorites. A micrometeoroid is a tiny particle, often smaller than a grain of sand. Every day, millions of meteoroids and micrometeoroids collide with Earth's atmosphere. Most of these particles never reach the surface, as they vaporize due to the intense heat generated by atmospheric friction. However, a micrometeorite is a micrometeoroid that survives its passage through Earth's atmosphere. These particles are a subset of cosmic dust and enter the atmosphere at incredibly high speeds, at least 11 kilometers per second. They can sometimes be seen as shooting stars. The Oort cloud. The Oort cloud represents the most distant region of our solar system. It's believed to be a vast spherical shell that encircles the rest of the solar system, resembling a massive, thick-walled bubble made of icy space debris, with objects ranging from the size of mountains to even larger. The Oort cloud may contain billions, possibly even trillions of objects. Though no spacecraft has yet explored the Oort cloud, 5 are on course to reach it. However, due to the immense distance, the power sources of these spacecraft will be long dead before they arrive. For example, Voyager 1 is currently traveling at a speed of 1 million miles per day, but won't enter the Oort cloud for another 300 years. Antimatter. Antimatter is identical to ordinary matter, except it has the opposite electric charge. For instance, while an electron has a negative charge, its antimatter counterpart, the positron, has the same mass, but a positive charge. When matter and antimatter come into contact, they annihilate each other, releasing energy. Antimatter was created alongside matter after the Big Bang, but it is now rare in the universe. The question of why matter dominates over antimatter remains one of the biggest mysteries in physics. Bird's legs, puffy face. Astronauts experience a phenomenon known as bird's legs, puffy face, due to the movement of fluids within the body in the microgravity environment of space. On Earth, gravity pulls fluids downward, but in space, this extra gallon and a half of liquid moves upwards, leading to a puffier face and thinner legs. Once astronauts return to Earth, their bodies gradually return to normal as fluids redistribute under the influence of gravity. The corned beef sandwich incident. The first corned beef sandwich to orbit Earth was smuggled aboard the Gemini 3 spacecraft in 1965. This contraband snack was not approved by NASA. Pilot John Young secretly brought the sandwich in a pocket of his spacesuit. However, when he took a bite, crumbs started floating around the cabin, which could have caused problems by getting into the equipment. Fortunately, no harm was done, and the incident remained a minor one in Young's illustrious career. He was the first person to fly in space 6 times, the first to orbit the moon alone, and the commander of the first space shuttle mission. Young's career as an astronaut spanned 42 years, longer than anyone else to date. Nuclear fusion. Fusion is a reaction in which 2 hydrogen atoms combine to form a helium atom, converting some of the hydrogen's mass into energy. Nuclear fusion occurs when 2 atomic nuclei are forced together, creating a heavier nucleus in the process and releasing a massive amount of energy. This process powers stars, including our sun, enabling them to generate light and heat. A star is born when light element atoms are compressed under sufficient pressure for their nuclei to undergo fusion. All stars result from a balance of forces. Gravity compresses atoms in interstellar gas until the fusion reaction begins. The Fermi Paradox. The Fermi Paradox highlights the apparent contradiction between the high probability of advanced extraterrestrial life and the lack of evidence for it. Given the vast number of planets and stars in the Milky Way, why have we not detected signs of intelligent life? Possible explanations include that we haven't searched thoroughly enough, that we are too far away, that aliens have visited without leaving any trace, or that we are alone in the universe, a possibility most scientists find unlikely. Interstellar travel, interstellar space travel, or travel between stars, poses much greater challenges than travel within our solar system due to the immense distances involved. The closest star to us is the Sun at 93 million miles. The next closest star, Proxima Centauri, is about 4.3 light-years away, or 25.3 trillion miles. The fastest spacecraft launched so far, Voyager 1, would take approximately 72,000 years to reach Proxima Centauri at its current speed. However, Voyager 1 was not designed specifically for interstellar travel, and advancements in technology could significantly reduce this travel time in the future. N-1 secret moon rocket. The N-1 was a Soviet rocket developed to compete with the United States in the race to the moon. Its development, and even its existence, was kept a state secret for many years. During its first test flight in February 1969, the N-1 exploded, tragically killing 91 people on the ground. This disaster was not revealed to the public until 1995. After 3 more failed attempts, the N-1 mission was officially canceled in 1976. Lost cosmonaut conspiracy theory. There is a conspiracy theory suggesting that the Soviet Union secretly launched several astronauts into space. According to the theory, these early missions ended in tragedy, and the Soviet government covered up the deaths. However, there is no solid evidence to support this claim, and it remains a myth. The secrecy surrounding Soviet space missions in the 1960s, which were only announced if successful, likely fueled this theory. Moon dust is dangerous. Inhaling moon dust could be potentially hazardous due to its high content of silicate, a material commonly found on planets with volcanic activity. On Earth, miners exposed to silicate can suffer from lung inflammation and scarring. Moon dust is extremely abrasive, wearing down layers of spacesuit boots and damaging vacuum seals on sample containers. It resembles a fine powder, but is as sharp as glass. Due to the moon's low gravity, these tiny particles remain suspended for longer and can penetrate deeper into the lungs. The potential long-term health effects of inhaling moon dust are unknown, but studies suggest that lunar soil simulants can damage lung and brain cells after prolonged exposure. Dark matter. Dark matter consists of particles that neither absorb, reflect, nor emit light, making it undetectable through conventional observation of electromagnetic radiation. Although it cannot be seen directly, scientists know dark matter exists because of its gravitational effects on observable objects. It is believed to constitute about 85% of all the matter in the universe, yet it remains a mystery, as we cannot touch it, see it, or manipulate it with current technology. Diamond planets. It is estimated that there are trillions of planets in the universe, primarily composed of diamonds. These carbide exoplanets contain far more carbon than Earth, and near their cores, they are thought to contain molten silicon carbide, a compound of silicon and carbon. Simulations have shown that under extreme heat and pressure, and with the presence of water, silicon carbide on such planets can transform into silica and form supercompressed carbon crystals, commonly known as diamonds. Solar sails. Solar sails are a technology that allows spacecraft to propel using radiation pressure from sunlight. The first spacecraft to utilize this technology was Icaros, launched in 2010. Since then, several solar sails have been deployed. It is believed that solar sail-powered spacecraft could reach distant planets and stars much faster than traditional rocket-powered spacecraft due to the continuous acceleration provided by solar sailing. The flags on the moon are now white. During NASA's 6 Apollo missions, astronauts planted American flags on the moon. Due to the intense sunlight and lack of atmosphere, all of these flags were quickly bleached white. It's also possible that some of the flags have disintegrated over time. Acceleration and gravity equivalence. In Einstein's theory of general relativity, the equivalence principle states that gravitational and inertial forces are similar in nature and often indistinguishable. For example, an astronaut accelerating through space at a certain rate would weigh the same as they would standing on Earth, according to a set of scales. In deep space, far from any gravitational source, you could stand in an accelerating spacecraft and experience a weight equivalent to what you would feel on Earth. Thus, acceleration and gravity can be indistinguishable. Titan's lakes. Titan, Saturn's largest moon, has lakes filled with liquid ethane and methane. Scientists believe that Titan might harbor a habitable environment, although the surface temperature is a frigid minus 180 degrees Celsius, far too cold for liquid water to exist. Cosmic inflation. Cosmic inflation is a theory that suggests the universe has been expanding at a rate faster than light since the Big Bang. Apollo 1. Apollo 1 was intended to be the first crewed mission of the Apollo program, aiming to land the first humans on the moon. However, the mission never launched. In February 1967, a cabin fire during a launch rehearsal tragically claimed the lives of all 3 crew members, Gus Grissom, Ed White, and Roger Chaffee. The WOW signal. In 1977, astronomer Jerry Eman detected a mysterious signal while scanning the skies with Ohio State University's Big Ear radio telescope. The signal, which lasted 72 seconds, was so striking that Eman circled the reading and wrote "Wow" next to it, giving the signal its name. However, it was later discovered that the signal was caused by 2 comets emitting hydrogen gas. Mir incidents. The Russian space station Mir operated continuously from 1986 to 2001, marking a significant milestone in space exploration. However, during its 15 years in orbit, it experienced some harrowing incidents. In 1997, the 6 crew members aboard Mir faced a life-threatening situation when a fire broke out, filling the station with smoke. Fortunately, the crew managed to extinguish the fire, and the station's systems cleared out the toxic smoke over several hours. Later that year, the same crew encountered another major crisis, the worst collision in space history. During a docking test, they lost control of a tumbling cargo ship, which collided with the station. Seconds later, they heard the ominous hissing sound of air escaping the vessel. Acting quickly, the astronauts were able to locate and secure the breach, averting disaster. Vladimir Komarov's sacrifice. In 1967, Soviet cosmonaut Vladimir Komarov faced an impossible situation. Komarov was a close friend of Yuri Gagarin, the first human to journey into outer space. The Soviet leader, Leonid Brezhnev, planned a spectacular mid-space rendezvous between two Soviet spacecraft. The plan involved launching the Soyuz 1 capsule with Komarov aboard, followed by a second vehicle carrying two more cosmonauts the next day. The two spacecraft would meet in orbit, and Komarov would transfer from one vehicle to the other before returning home in the second ship. However, Gagarin and other senior technicians had inspected the Soyuz 1 capsule and discovered 203 serious structural flaws, making it too dangerous to fly. Gagarin even wrote a 10-page memo detailing these issues and gave it to a KGB friend, but no one dared to pass it on to Brezhnev. Everyone involved with the memo, including the KGB officer, was later demoted, fired, or sent to Siberia. Komarov knew the mission was doomed. He confided in a KGB agent, saying, "I won't make it back from this flight." When asked why he didn't refuse, Komarov replied that if he didn't go, Gagarin would be sent in his place, and Komarov couldn't let that happen to his friend. On launch day, Gagarin unexpectedly showed up, demanding to be suited up for the mission, but it was too late. Komarov had already boarded the capsule. As feared, the Soyuz 1 encountered multiple failures during the mission, leading to the cancellation of the second launch. On his descent back to Earth, Komarov's cries of frustration and curses at those who sent him on the ill-fated mission were recorded. Tragically, he died when his parachute failed to deploy, making him the first human to perish during a spaceflight. Gay astronauts. Since the inception of NASA's human spaceflight program, 330 American men and women have served as astronauts. However, none were openly gay during their service. Only one, Sally Ride, the first American woman in space, is known to have been gay or bisexual, a fact that was not revealed until after her death. Her obituary disclosed that she was survived by Tam O'Shaughnessy, her partner of 27 years. Quasars. Quasars are the brightest and most distant celestial objects known in the universe. These incredibly luminous objects are so bright that they outshine all the stars in their host galaxies. Quasars emit energies in the range of millions, billions, or even trillions of electron volts, and they are believed to be powered by supermassive black holes at the centers of their galaxies. In 2017, astronomers discovered the most distant quasar ever observed, located over 13 billion light-years from Earth. This quasar is thought to have formed just 690 million years after the Big Bang, providing crucial insights into the early stages of galaxy formation and evolution. The Carrington Event. The Carrington Event of 1859 was the most intense solar storm ever recorded. In August of that year, astronomers, including amateur skywatcher Richard Carrington, observed a sudden increase in sunspots on the sun's surface. On September 1st, while sketching these sunspots, Carrington witnessed a blinding flash of light, a white light flare, marking the first recorded observation of a solar flare. This flare was part of a major coronal mass ejection, CME, a burst of magnetized plasma from the sun's atmosphere. Within 17 hours, the CME traveled the 90 million miles from the sun to Earth, triggering a massive geomagnetic storm the following day. The storm caused widespread disruptions, particularly in telegraph systems, which malfunctioned due to the intense geomagnetic activity. Reports of sparks flying from telegraph machines, operators receiving electric shocks, and papers catching fire were widespread. The storm also produced spectacular auroras, with the northern lights visible as far south as Cuba and Hawaii, and the southern lights seen as far north as San Diego. If a solar storm of this magnitude were to occur today, it could cause catastrophic disruptions to global electronic systems, leading to widespread blackouts and an internet apocalypse. Despite the chaos, the Carrington event had no significant impact on human health or other life on Earth. Tabby's star, named after Professor Tabitha Boyajian, is known for its unusual fluctuations in brightness. These irregular dimming patterns suggest that something is passing in front of the star and blocking its light, but the cause remains a mystery. The patterns observed are not consistent with a planet or even an alien megastructure, as previously speculated, leading to ongoing investigations into the star's unique behavior. Saturn's rings will disappear. NASA research has revealed that Saturn is gradually losing its iconic rings, and at the current rate, they could vanish in about 100 million years. This time span is relatively short compared to Saturn's age, which exceeds 4 billion years. The rings, composed primarily of large chunks of ice, are falling onto the planet as ice rain due to Saturn's intense gravity. This phenomenon occurs because micrometeorites, solar wind particles, UV radiation, and electromagnetic forces are disturbing the electrically charged dust in the rings, causing it to be pulled towards Saturn by its gravitational field. Solar eclipses are coincidences. A solar eclipse happens when the moon passes between the sun and Earth, casting the moon's shadow on Earth. Total solar eclipses, where the moon nearly perfectly covers the sun, are remarkable coincidences. If the sun were slightly larger or the moon a bit further away, total solar eclipses wouldn't occur. The moon's diameter is almost exactly 400 times smaller than the sun's, and the sun is almost exactly 400 times farther from Earth than the moon. This near-perfect ratio makes the apparent sizes of the sun and moon from Earth nearly identical, allowing for the phenomenon of eclipses. Gravity is not a force. In physics, a force is an influence that causes an object with mass to change its velocity, such as accelerating. However, Einstein's theory of general relativity redefined our understanding of gravity. He proposed that gravity is not a force, but rather a curvature of space and time caused by mass and energy. In this view, gravity is an effect of the warping of space-time in the presence of mass. Without a force acting on it, an object would move in a straight line. Numerous experiments have shown that gravity is indeed an effect of space-time, integral to the very structure of the universe. Martian canals. During the late 19th and early 20th centuries, it was widely believed that there were canals on Mars, networks of long, straight lines visible in the planet's equatorial regions. These canals were observed by astronomers using early telescopes without the aid of photography. In 1877, Giovanni Schiaparelli, the director of the Milan Observatory, began mapping and naming features on Mars using historical and mythological sources for names. He observed channels on Mars and called them canali, which means channels in Italian. However, this term was mistranslated as canals, leading people to believe that intelligent life on Mars had built them. Later, photographs taken by NASA's Mariner spacecraft showed that there were no canals at all. What had been observed was merely an optical illusion. Buran. Buran was the first spaceplane produced by the Soviet Union, designed similarly to the U.S. Space Shuttle. Buran completed its first and only unmanned spaceflight in 1988. A second flight was planned for 1993, but the dissolution of the Soviet Union led to funding cuts, and the mission never took place. In 2002, the Buran spacecraft was destroyed when the storage facility it was housed in collapsed, killing 8 workers. Soyuz 11 was the first successful mission to dock with the world's first space station, Salyut 1. However, the mission ended in tragedy when the crew capsule depressurized during preparations for re-entry, killing the 3-man crew by asphyxiation. They remain the only people to have died in outer space. Despite this, Soyuz 11 returned to Earth with a perfect automated landing, carrying the bodies of the crew. Space-time might be 4D. According to Einstein, to describe your location in the universe, you need to consider not only 3-dimensional space, length, width, and height, but also time as a 4th dimension. Space-time is a mathematical model that combines these 3 dimensions of space and 1 dimension of time into a 4-dimensional continuum. This concept is central to the theory of general relativity. However, some theorists believe that space-time may not be a fundamental reality, but rather an illusion. Human ashes in the outer solar system. The concept of space burials, where human remains are launched into space using rockets, has been around since 1997. Space burials may involve sending remains into orbit around Earth, to extraterrestrial bodies like the Moon, or even further into space. Typically, only small samples of remains are launched to reduce costs. The private company Celestis has been offering space burial services since 1997. They provide options like Earthrise, which sends remains into space and then returns them to Earth, or Earth Orbit, where remains are sent into space and then vaporize upon re-entry like a shooting star. The most expensive service, Voyager, sends remains on a permanent journey into deep space. The first space burial took place in 1992, when a sample of Star Trek creator Gene Roddenberry's ashes was carried into space aboard the NASA Space Shuttle Columbia before being returned to Earth. Pioneer Anomaly. In 1972, Pioneer 10 became the first spacecraft to pass through the asteroid belt, capture close-up images of Jupiter, and then journey beyond Pluto. Pioneer 10 carries a gold plaque depicting what humans look like, where we are located, and the date the mission began. This spacecraft will continue its silent voyage through deep space, eventually entering interstellar space. It is heading towards the red star Aldebaran, located in the eye of the Taurus constellation, and it will take Pioneer 10 more than 2 million years to reach it. Pioneer 11, its sister ship, was launched on a similar trajectory, but ended its mission in 1995 when it stopped transmitting signals. The Pioneer Anomaly refers to the unexpected change in speed observed in both Pioneer 10 and 11 as they traveled away from the Sun. While some deceleration was expected due to the Sun's gravitational pull and other forces, the spacecraft slowed down more than anticipated. After 20 years of mystery, it was concluded that radiation forces generated by the heating of the spacecraft and their electronics were sufficient to explain the Pioneer Anomaly. Martian waterfalls. While Mars has no liquid water today, evidence suggests that the planet once had lakes and waterfalls billions of years ago. In Valles Marineris, there are dried riverbeds stretching over 2,400 kilometers and massive dried-up waterfalls, some 10 times taller and 100 times wider than Niagara Falls. Additionally, there is evidence of lava falls, where molten lava once flowed similarly to liquid water, carving out massive channels on the Martian surface. Space blindness. Many astronauts have reported deteriorating eyesight, a condition now known as spaceflight-associated neuroocular syndrome, SAND. This syndrome affects 80% of astronauts on long-duration missions in space. Researchers believe that the visual issues stem from increased pressure within the skull due to the lack of gravity. Studies conducted on 27 astronauts who spent 108 days or more in space revealed that a third had an expansion of cerebrospinal fluid around the optic nerves, 15% had bulging optic nerves, and 22% experienced a flattening of the backs of their eyeballs, leading to untreatable nearsightedness. Space blindness can begin to manifest after just a few months in space, raising concerns for future Mars missions, which currently require around 20 months of travel. Elon Musk has stated that the first Mars colonists must be prepared for all challenges, including potential loss of vision. STS-7. STS-7 was NASA's 7th Space Shuttle mission and the second mission for the Space Shuttle Challenger in 1983. During this mission, one of the shuttle's windows was non-critically damaged by a tiny piece of paint. This seemingly minor incident would later become a significant factor in the tragic loss of the Space Shuttle Columbia and its crew nearly 2 decades later. Penis on the Moon. The Moon Museum is a small ceramic tile featuring art from 6 artists of the 1960s, including Andy Warhol, who contributed a drawing of a penis in the top left corner, Robert Rauschenberg, David Novros, Forrest Myers, Claes Oldenburg, and John Chamberlain. This tile was reportedly secretly attached to a leg of the lunar module Intrepid and left on the Moon during the Apollo 12 mission in 1969. The Moon Museum is considered the first space art object, although its existence has not been officially confirmed. Oumuamua Spaceship Conspiracy. Oumuamua is the first known interstellar object to enter our solar system, discovered in 2017. Initially thought to be a comet, it exhibited an unusually elongated shape and behavior unlike any known asteroid or comet in our solar system. Its brightness varied significantly, leading to speculation that it might be an alien spacecraft. Some scientists noted that the object appeared to accelerate, which led a Harvard astrophysicist to propose the theory that it was being propelled by an alien machine, such as a light sail. However, Oumuamua has since passed Neptune in 2022 and is now on its way out of our solar system, beyond the reach of any telescope. Dark energy. Interestingly, the universe's expansion initially began to slow down around 7 to 8 billion years after the Big Bang. However, a mysterious force, now known as dark energy, started to dominate, reversing this deceleration and causing the universe to expand at an accelerating rate. Dark energy is the term given to this unknown force that drives the universe's accelerating expansion. While we can observe its effects on the universe, its true nature remains a mystery. Dark energy is estimated to make up about 68% of the universe, with dark matter comprising roughly 27%, leaving only 5% as ordinary matter. The Great Attractor, our galaxy, along with nearby galaxies, is being pulled toward a specific region in space, about 150 million light-years away, beyond the other side of the Milky Way. This area, obscured by the Milky Way's galactic plane, is known as the zone of avoidance, making it difficult to observe. Despite this, scientists have identified the mysterious force pulling galaxies toward it as the Great Attractor. Discovered in the 1970s, it was found that the Milky Way is moving through space toward the constellation Centaurus at about 600 kilometers per second. Around 400 elliptical galaxies have also been found moving in the direction of the Great Attractor, although what exactly lies in this region remains uncertain. String theory. String theory is a concept in theoretical physics proposing that reality is composed of infinitesimally small, vibrating strings, smaller than atoms or electrons. According to the theory, these strings vibrate, twist, and fold, generating effects in numerous tiny dimensions that manifest as everything from subatomic particles to large-scale phenomena like gravity. Current versions of string theory suggest there are 10 or 11 dimensions in total. Although no experiment has conclusively proven string theory as the fundamental theory of nature, its ideas have passed many theoretical and mathematical tests over the past 50 years. Venusian dinosaurs. In the 17th century, the Italian astronomer Galileo Galilei used his telescope to observe Venus and noticed that it appeared featureless. He concluded that Venus was shrouded in thick clouds, blocking the view of its surface. One of Galileo's more imaginative speculations went something like this: "I can't see the surface of Venus because it's covered with dense clouds. These clouds must be made of water, which means the surface is likely wet, perhaps even swampy. If there are swamps, there could be reeds, and if there are reeds, maybe even dinosaurs." Today, we know that Venus has no liquid water, as its surface temperature exceeds 800 degrees Fahrenheit, making it inhospitable for any form of life, let alone dinosaurs. Strange quarks. Quarks are subatomic particles that are considered fundamental, meaning they cannot be broken down or divided any further. Among these, strange quarks have a unique property. They resist decay against the strong nuclear force and electromagnetism. This means that any particle containing a strange quark does not decay through the strong force, but instead decays more slowly via the weak force. The name strange quark derives from this unusual method of decay. Many worlds. The many worlds interpretation is a concept in quantum mechanics that suggests the existence of multiple copies of ourselves living in parallel worlds. Our universe is just one of many parallel worlds that continually branch off from one another, nanosecond by nanosecond, without ever intersecting or communicating. Some cosmologists believe the many worlds interpretation offers the best explanation for the existence of the universe as we know it. Zuma disappearance. Zuma was a classified U.S. government satellite launched by SpaceX in 2018. Due to its classified nature, details about its mission and fate are unclear. SpaceX reported the mission as successful, but reports from Bloomberg and other news outlets suggest that the satellite malfunctioned in orbit, causing it to fall back to Earth and crash into the ocean. Another possibility is that the spacecraft was lost after reaching outer space, as there were reports of an unidentified object seen in orbit, which may have been the Zuma satellite. Starquakes. Starquakes occur on neutron stars, which are the remnants of supernova explosions. These stars are composed entirely of neutrons and have a solid crust. A starquake can alter the rotation and tilt of a neutron star. These quakes happen when small fractures form in the star's solid crust, allowing matter from the star's interior to seep out. This matter forms incredibly tiny yet dense mountains, thinner than the head of a pin. Due to the difference between the rotational and magnetic axes of the star, these mountains cause an imbalance on the star's surface. This imbalance results in a sudden adjustment, where the star emits massive amounts of energy, primarily in the form of X-rays. One type of starquake has been recorded at 20.1 on the Richter scale, releasing over 1,000 times more energy than a magnitude 7 earthquake on Earth. Lorentz factor. According to Einstein's theory of special relativity, an object at rest and the same object in motion exhibit different physical properties, such as length, mass, and time. The Lorentz factor is a number that represents these changes in an object's physical properties as it moves at different speeds. The Lorentz factor is crucial in calculating time dilation, which is the slowing of time as perceived by one observer compared to another, depending on their relative motion or positions. For instance, if you fly from Boston to Los Angeles, you will age faster than people on the ground. However, when you fly back from Los Angeles to Boston, you will age more slowly due to the extra speed you gain by moving with the Earth's spin. The final parsec problem. A parsec is a unit of distance equal to 3.2 light years, or about 19 trillion miles. In astronomy, a binary black hole system is where two black holes are in close orbit around each other. The final parsec problem refers to the uncertainty about whether two supermassive black holes can merge. The problem suggests that all binary black holes will stall at about 1 parsec apart, where their orbits will take an infinite amount of time to decay further, preventing them from merging. Soyuz TMA-11 superstition. Soyuz TMA-11 was a human spaceflight mission to transport personnel to and from the International Space Station. The mission began in October 2007 and successfully brought 2 crew members to the station. The Soyuz TMA-11 capsule remained at the station and returned to Earth in April 2008 after being replaced by Soyuz TMA-12. Although the capsule landed safely, it suffered a malfunction that caused it to land 475 kilometers away from its intended landing site. One of the astronauts on board sustained a minor injury and had difficulty breathing. This was the second consecutive time such a malfunction had occurred with a Soyuz mission. The head of the Russian Federal Space Agency, Anatoly Perminov, speculated that the malfunction might have been due to a Russian superstition, which claims that having more women than men on board is unlucky. The return flight of Soyuz TMA-11 was the first time 2 women flew together on board a Soyuz capsule. Perminov stated that this belief was not discriminatory, but suggested that when the majority of the crew is female, certain kinds of unsanctioned behavior or other factors might occur. He mentioned that efforts would be made to ensure that future crews have a balanced gender ratio. Moons with rings. Rings are one of the most prominent features of the Saturn system. Saturn's rings are about 30 feet thick and consist almost entirely of billions of chunks of ice, ranging in size from smaller than a grain of sand to as large as a mountain. Rhea, the second largest moon of Saturn, may have its own ring system consisting of 3 narrow, dense bands. This would be the first discovery of rings around a moon. One possible explanation for Rhea's rings is that they are remnants of an asteroid or comet collision in Rhea's past. Such a collision could have ejected large amounts of gas and solid particles around Rhea. As the gas dissipated, only the ring particles remained. Other moons of Saturn also show evidence of catastrophic collisions. The end of greatness. When we examine the universe at its largest scale, it seems to be uniformly filled with random superclusters of galaxies. A supercluster is a massive collection of smaller galaxy clusters and is among the biggest structures we know of in the cosmos. However, this apparent uniformity breaks down when we zoom in and observe the universe on a smaller scale. Astronomers refer to this breakdown in uniformity as the end of greatness. The unification of fundamental forces. In the 19th century, physicists successfully combined electricity and magnetism into a single force known as electromagnetism. Later, they connected another force, the weak force, with electromagnetism, forming what is now called the theory of electro-weak interactions. Some scientists believe that the next logical step is to unite all four fundamental forces, gravity, electromagnetism, the weak force, and the strong force, into a single, all-encompassing force. This would result in a theory of everything. However, since these forces are quite different, this theory remains unachieved. CMB and quantum fluctuations. As mentioned earlier, the cosmic microwave background, CMB, is the residual radiation from the Big Bang. A quantum fluctuation is a temporary shift in the amount of energy at a specific point in space. For instance, if you place a marble at the bottom of a bowl, it will stay there indefinitely. However, if you place a very lightweight particle in a tiny bowl, it won't remain still but will move around. This movement is due to quantum fluctuations. It is believed that these quantum fluctuations led to the fluctuations observed in the CMB. The Boltzmann-Brane paradox. The Boltzmann-Brane is a thought experiment that suggests it might be more probable for a single brain to spontaneously form in the void, complete with false memories of having lived in our universe, than it is for the entire universe to have formed as we know it. If you were a Boltzmann brain, then nothing in the universe might actually be real. Dark flow. Dark flow describes the motion of hundreds of galaxy clusters heading in a specific direction towards a region between the constellations Centaurus and Vela, possibly moving toward what is known as the Great Attractor. These galaxies have been observed traveling at speeds ranging from 1.3 million to 2.2 million miles per hour in this direction. Photons experience no time. A photon is a minuscule particle made up of waves of electromagnetic radiation. Photons are simply electric fields traveling through space. They have no charge, no mass, and they move at the speed of light. If you could travel at the speed of light, time and space would no longer function the way they do normally. For a photon, there is no passage of time because, relative to a photon, no time passes at all. Quantum immortality. Quantum immortality is the idea that a person might experience surviving an event that should have been fatal due to quantum effects. In the thought experiment known as quantum suicide, every time a person attempts suicide, the universe splits into multiple realities, with at least one reality in which the person survives. This leads to the notion that the person could experience quantum immortality. Holographic universe. The holographic universe theory suggests that all the information that makes up our three-dimensional reality is actually stored on a two-dimensional surface, including time itself. This means that everything we perceive and experience could be an illusion. Some theoretical physicists have found irregularities in the cosmic microwave background that lend significant support to the holographic model of the universe. The one-electron hypothesis. The one-electron universe hypothesis proposes that every electron in the universe is actually the same particle, continually moving back and forth through time. Everything is a spime. The term spime was coined by Bruce Sterling in 2004, combining space and time. A spime is a theoretical object that can be tracked through space and time over the course of its existence. An object can be considered a spime when all its essential information is stored in the cloud. Sterling believes that in the future, all objects may eventually become spimes. Astronaut Edgar Mitchell believes in UFOs. Edgar Mitchell, renowned for his crucial role in saving the Apollo 14 mission during its 1971 moon landing, also held some intriguing beliefs about UFOs. He claimed that top military officials had concealed evidence of extraterrestrial spacecraft, which were frequently seen hovering over the White Sands testing range in New Mexico. White Sands was used for testing atomic weapons, and Mitchell believed that extraterrestrials were particularly interested in our military capabilities. According to Mitchell, based on conversations with insiders, these alien visitors had intervened to prevent nuclear wars, even going so far as to disable and shoot down nuclear missiles over the Pacific. Mitchell, a highly respected pilot, was not known for making outlandish statements. False vacuum. A vacuum is typically defined as a space devoid of matter or energy, though in reality only partial vacuums can be achieved. A false vacuum is a theoretical state that is not completely stable, but rather metastable, meaning it could persist in that state for an extended period before potentially transitioning to a more stable state in an event called false vacuum decay. It's thought that if the universe were to come to an end, false vacuum decay could be the most efficient way for that to happen. The solar system is a zoo. The zoo hypothesis suggests that advanced alien civilizations are aware of our existence but choose to deliberately hide from us. Astrobiologist Douglas Vakoc likened this to how humans observe animals in a zoo. He wondered how we could get these galactic zookeepers to reveal themselves. Vakoc proposed that we should intensify our search for extraterrestrial intelligence. He likened it to visiting a zoo, where if a zebra suddenly turned to us, looked us in the eye and began reciting prime numbers, we would be compelled to respond, establishing a fundamentally different relationship. Higher dimensions, folded at the Planck length. The Planck length is an extremely small scale used to describe the point at which our current understanding of gravity breaks down. It's considered the smallest measurable length. Higher dimensions refer to spatial dimensions beyond the familiar three: length, width, and height. The theory suggests that these extra dimensions might be so minuscule that we cannot perceive them, as they could be folded up at the Planck length. The universe might be a fundamental particle. This concept posits that our universe could be just one of many that make up the fundamental particles of an even larger universe or multiple universes. The axis of evil is a term used to describe the strange alignment between the plane of our solar system and certain features of the cosmic microwave background, CMB. This alignment suggests that the plane of our solar system and Earth's position might have more significance than random chance would allow, which contradicts the Copernican principle, the idea that Earth does not hold a special or central place in the universe. Reality is just information. This theory, put forth by scientist and philosopher Carl Friedrich von Weizsäcker, argues that reality might be nothing more than a collection of information. Since all particles can be described by various properties like momentum, charge, spin, and mass, it's possible that reality itself is just a set of informational data. According to this theory, matter is an illusion, and the only truly real thing is information. Weizsäcker suggested that only the mathematical structures used in scientific theories are real, not the physical world these theories were created to describe. Essentially, the universe exists because we perceive it, much like a collective hallucination used to understand the mathematical relationships between objects. Living stellar objects. The theory of living stellar objects suggests that the key ingredient for life is abundant energy, which stars possess in great quantities. Author Robert Forward imagined a type of life that could thrive on dense neutron stars. Physicist Frank Drake speculated that such life forms would be microscopic, composed of atomic nuclei rather than complete atoms, and would be flattened due to the intense gravity. These life forms would resemble amoebas, living and dying in mere milliseconds. In some older, more ordinary stars, it might be possible for life to develop in the form of hard tungsten spheres, only a few micrometers across. Certain brown dwarf stars, which have surfaces as cool as room temperature, could potentially harbor more complex organisms that float in their atmospheres, absorbing radiation as their food source. Another universe seen in the CMB. A wormhole is like a shortcut through space, connecting two distant points in the universe and drastically reducing the time it takes to travel between them. Instead of spending millions of years traveling from one galaxy to another under the right conditions, you could theoretically use a wormhole to make the journey in just hours or minutes. Wormholes are consistent with Einstein's general theory of relativity, though their existence has yet to be proven. This theory about wormholes and time travel suggests that black holes could serve as gateways or entrances to these cosmic tunnels. To illustrate this, imagine you create a wormhole with two ends, A and B. If you leave end A in place and take end B on a high-speed journey through the universe for a year at nearly the speed of light, end B would experience less time than end A, according to the effects of general relativity. When you reunite the two ends, one might be hundreds of years older than the other, but they would still be connected. If you then pass through end B and exit at end A, you could find yourself emerging hundreds of years in the past. If you believe that black holes have corresponding white holes, where matter enters on one side and exits on the other, then you might assume that these space-time tunnels could allow for travel backward in time. All energy can be represented as a single wave. This theory resembles the one-electron universe hypothesis, but applies to all energy. It proposes that reality could be interpreted as a single wave oscillating back and forth through time, changing its properties to produce what we perceive as particles. These particles interact with both their past and future versions, resulting in the formation of atoms and the matter we experience in the universe.